In this section, chapter 12, we're going to talk about exception handling, text input and output. We're going to start with exception handling. So here is the problem. When a program runs and if it has a runtime error, the program is going to terminate abnormally. We're going to fail. We're going to get that error message, that dreaded message that an exception has occurred. How can we handle those runtime errors so that our program doesn't crash? We can make our program either continue or we can at least handle the error gracefully instead of just having a funny error thrown up to the users. That's what we're going to look at in this chapter. Let's take a look at some code that causes runtime errors. And I want to point out that these PowerPoints come from the publisher of the book, and they are available in my resources folder. So if you go there and run these, when you click on these links, it will take you to a web page that has an interactive Java compiler that you can run over the web. However, I would highly suggest that you take the code from there and you try to put it into your regular IDE. In this course, we're using NetBeans. So take some of that code and put it into NetBeans and try it in there and experiment with it in there. But for some of these demos, I am going to use their site because the fonts are nice and big and it's got a nice interface that's easy to read on the presentation. So let me pull up these examples and show them to you. So here we go. Here. So here's our first example. So we have a very small program here. We have a main method and it creates a scanner and prompts the user and asks the user to enter two integers. So we have two inputs, enter next int and input another next int, and it's storing them in these two variables, number 1, number 2, and then it's going to attempt to divide those two numbers and print out the result. So let's actually run this so we can run examples live. And we have this little editor up here, and down here are the results. And if I hit compile and run, it's going to run this using the inputs 1 and 0. So I can put numbers in here that are going to be parsed for the two inputs that we saw. It was parsed here for the first one, here for the second one. So number 2 was set to 0, and then we tried to divide number 1 by number 2, and the result was that we threw an exception, division by 0. In line 12, we try to divide something by 0, and we have an arithmetic exception that was caused by division by 0. All right, so let's look at a way we might fix this. One of the ways we might fix it would be like this. We still ask the user for two integers, and we get those two integers, but now we use an if statement to check to make sure that the number is not equal to 0. And if the number is equal to 0, if the number is equal to 0, we run the else statement that says, hey, the divisor cannot be 0, and then our program ends, and they would have to run it again until they enter something for number 2 that's not equal to 0. So we can run this. And we ran it with an n0, 1 and a 0, and it said divisor cannot equal 0, and the program exited. And that's okay, but the problem with if statements, doing things that way, is that as we check for more and more and more errors, our code can get very long and very cumbersome and very hard to read because all those if statements checking the different things that need to be checked are mixed right in with the code that we actually want to execute. And it gets pretty complicated. Let's look at this one. What do we have here? Now we're using a method. Okay, so down here we're asking for the two numbers, and then we're calling this quotient method with number 1 and number 2. And up here is the method that actually does the calculations. And again, we're using an if statement in the method and printing out the divisor cannot be 0, and then we do a system exit with a 1. System exit with a 1 means things were not successful. But if the number is not equal to 0, we return the result, and it gets printed down here. Still not very graceful. All right, so there's 2 different ways to try and avoid the possibility of getting an error. The last way we're going to look at is still using the quotient method. Okay, accepting the 2 numbers. So we ask the user for input 1 and 2, and then down here we use something called a TryCatch block. So the try block says call the quotient method with number 1 and number 2. Okay. And the result should come back and it gets printed out to the user. But if something bad happens, like an arithmetic exception, it's going to print out a nice error that says exception and integer cannot be divided by 0. And then we can have more code that comes after this, and it will work just fine. Let's go up and look at what happens up here. Now we're using an if statement up here to check to see if the number is equal to 0. And if it is, rather than doing something fancy, we are doing something fancy. We're throwing, so this keyword throw here, a new arithmetic exception with the error divisor cannot be 0. Let's run this. And when it runs with 1 and 0, we printed out that there, in a friendly way, that there was an exception and the execution of our code could continue. Looks like they're wanting us to actually write the code here. Let's try this again. Let's do throw up here. So we have to throw the exception. And down here is our try block. Here is our catch. Okay. All right, so it works. I think it just wanted to quiz us there. I haven't used these a lot, but you're more than welcome to use them. It's a nice way to practice some of the demos that are also in the book. So this is a better way. We have the try. We try to do something. If that something doesn't work, we throw an exception, and then we have code to catch it. Now, you may not have seen it. If you've used these before, you may not have seen it this way. But the idea here is that we don't, because some people might say, well, why don't you just do try catch up here in the method? And the idea is that we don't do try and catch in our methods. We want to make them modular. If they do anything, they throw it. And wherever we call the method, so right here we're calling the quotient method, that call should be in the TryCatch block. So we let the catch handle those exceptions wherever the method is being called, not in the method itself. Method will throw it. The catch block will catch it. All right, let's look at one more example. Let's see. This is an input mismatch demo. So we're going to look at a different kind of exception called an input mismatch exception. We have a scanner. We have a Boolean. So this is how to make our program more graceful and not shut down. We have a continue input equal true. And then we have a loop. So we have a do loop. And the condition is while continue input. So as long as continue input stays true, this entire loop will keep executing. And what does this loop do? It asks the user for an integer. And the user, we're using next int to parse an integer and store it in this number. So one of the things that could go wrong here is that next int could throw an exception if the user types something besides an integer. If they type a word or phrase that is not a number, it's not going to be able to parse it correctly. It's going to throw an exception. But if they do it okay, if this actually works, so we're going to try to do this. If it works, we're going to print the number out. And then continue input's going to be set to false, which means our loop test down here will test false and the program will end. However, if they don't make a good entry up here, if they type in a word or something or have letters in their input instead of an integer, and the exception runs, it's immediately going to error and come down here to catch. It's going to catch the input mismatch exception, and we're going to print out try again. An integer is required, and then we're asking for input again. And because this is in a loop and this will still be true, the loop will run again and it will try to ask them for another. It'll discard any input that's left and come up here and ask them again for another integer. And this will continue to try to run. But every time they put in invalid data, the catch will run, discard anything they had typed in, and make this ask them over and over and over till they get it right. So let's run this. We'll compile and run it live here. We do need this to be the try, this to be the catch. So these exercises can help you get ready to do your code, and we'll hit compile and run. Here they put in 3.5, which is not an integer. This again. Okay, I left off. The catch statement needs to specify what we're trying to catch. Input mismatch exception, and we'll give it a variable name because this actually throws an exception object, which we'll talk about more in a little bit. So we're assigning it to this variable EX. Try it. All right, now it works. So we're running this with the value 3.5. When we try to parse that as an integer, it fails. So it immediately comes down to the catch statement. And since it throws an input mismatch exception, it's going to run this catch statement. And it's going to print try again, incorrect output, an integer is required. And that's what happens. And because continue input is still true, after it reads the next line, that's basically to flush anything else the person may have typed. Continue input will be true. It will retry the do loop and try to execute this again, this time with the value 4 that we put in. And 4 will parse just fine. So it prints the number entered is. Enter an integer 4, the number entered is 4. Continue input is false, so this time when it gets to the while statement, it's false and it does not repeat the loop and the program ends gracefully. So this is a good way when using to get user input, using a try catch to make sure you're validating their input, and it will keep asking them for the correct input until they get it right. All right, in the next set of videos, we're going to look at the different types of exceptions. We talked about a couple of them in this video, but we'll look at a large set and subsets of exceptions that can be thrown in Java.